Hello, so today we are looking at geometric mean. I will warn you that this can be a difficult thing and topic to see for a lot of students. So just bear with me and pause the video as needed and rewind and watch parts. So the lesson objectives: use geometric means to solve parts of a right triangle and find the altitude to its hypotenuse. So first, on the top of your sheet here, you will see squares, and we want to determine the area of the dotted rectangle that is bounded on the two sides by squares. So the area of the squares are given, and the figures are not drawn to scale. So here, we want to know what the area of this blue rectangle is. So here, this side length, since the area of this square is 9, we get each of these sides to be 3. And here, since the area is 4, we get each side to be 2. So therefore, the dimensions of this rectangle are 3 by 2, so we get the area to be 6. So 2 times 3 equals 6. For B, we get our side length to be 5. And down here, we get our side length to be 4. So 4 times 5 gives us an area of 20. Here, we get the side length to be the square root of 2 and the square root of 8. If we multiply those two together, we get the square root of 16. But note here that the square root of 16 is 4. So be simplifying your square roots. Here, we get the square root of 2 times the square root of 18. So we get the square root of 36. Simplifying, we get an area of 6. For E, we get the square root of 1/4 times the square root of 1/9. So that gives us the square root of 136, which gives us the square root of 1 over the square root of 36. So we get 1/6. Carrying on in this pattern, we get the square root of 0.16 times the square root of 0.18. So we get 0.36. So in general, we get the square roots times each other. So the square root of a squared is just a. The square root of b squared is b. Here, again, we take the square root of a times the square root of b. So we can write that as 1 square root. So the square root of a times b. So be trying those. Note where all those numbers come from. Here we want to observe the relationship between the 4 and the 6. So that's 4/6, so we're going to write that right here. And then we want to look at between 6 and 9. So between 6 and 9. So note that cross multiplying, we get 4 times 9, we get 36. And 6 times 6 gives us 36. Also note that 4/6 is 0.667 and 6/9 is 0.667. So this is saying that these two numbers are the same, and so 6 is called the geometric mean of 4 and 9. So trying this sheet here, we want to find the geometric mean by cross multiplying. So we get that in this first one, we have 4 over x equals x over 9. So we're going to get that x squared equals 4 times 9, which gives us 36. So then taking the square root of both sides, we get that x is 6. So that says that the geometric mean between 4 and 9 is 6. Carrying on in this pattern, for b, we get the square root of 16 times 25, so we get 20. For 2, we get the square root of 2 times 8, so the square root of 16, and that would be 4. Carrying on, we get 2 times 18 to give us 36, so the square root of that is 6. Hopefully you should be seeing a pattern here. Get 1/6, 0.36, a, b, because we would take the square root of a squared times b squared. So that just gives us ab. For h now, we're going to get the square root of a times b. And now you should note that all of those that we just did, A through H, match up with A through H above in the figures. All right, for the bottom one here now, we get x squared equals 2 times 4, which gives us 8. So taking the square root of both sides, we get x equals the square root of 8. But we want to simplify this. So just a quick note on simplifying square roots. You can write this as the square root of 4 times 2. So you can write that as the square root of 4 times the square root of 2. And the square root of 4 is 2. So we can write 2 square root 2. All right. So for I then, we just said that that is 2 square root of 2. For j, we're going to get the square root of 18, which we can simplify to 3 square root of 2. And then k, we're going to get the square root of 12, which we can simplify to 2 square root of 3. And then L, we get the square root of 50, so we get 5 square root of 2. So go back to the beginning of this page if you still want to see how to do some of this, but you should see the pattern. Come in and ask for questions. All right, so we want to know what triangle is similar to triangle ACD. So ACD, and we need to be able to justify it, okay? So note here we have a right angle. We also see a right angle down here in C. So we can say that angle C is congruent to angle D. And then we can also note that angle A is congruent to angle A. So we can again see that our medium triangle is congruent to our big triangle. So we can say that triangle ACD is similar to triangle ABC. And that is by angle. So now we want to look at our small triangle. We want to know what triangle is similar to CBD. And again, we have our right angles. And then this time though, we have B is congruent to B. So then we have that triangle CBD is similar to our big triangle of CB. Sorry. So CBD is similar to a triangle ABC. So since both our medium and our small triangle are similar to our big triangle, we can say that triangle ACD, which is our medium one here, is similar to our big triangle. So our triangle ABC, which is then in turn similar to our small triangle CBD. So these are a little tricky to see, but make sure that you can see all three triangles there. We'll draw them on the next page. So let's first draw out all three of our triangles. We have our very big triangle, and that is A, B, C. And then we have a medium triangle in there. And that triangle is A, D, C. And then we have a small triangle. That is our C, D, B. All right, on your notes, you will see that we have this labeled as H, this labeled as B, this labeled as A, and then up here we have X and Y. So let's label our three triangles on here. We have AC is B, so we see that a couple places. We have that AD is Y, so we have AD right here. So this is Y. And we have that BD is X. And then we have DC is H. And then we have BC is A. And then this whole length is C. All right, so B over A, note here we have B over A equals Y over H of our medium triangle, and then H over X of our small triangle. I'm going to quick label this as A. So this is telling us that cross multiplying, we're going to get that H squared equals YX. Now hang with me a little bit more. So we have B over H now, and we see that over here. So we have B over H. On our big triangle, that equals C over A. And on our little triangle, we have that to be A over X. So cross multiplying, we're going to get that A squared equals CX. Our last one, we have A over H. And so we're going to get on our medium triangle, B over Y. And then our large triangle, we're going to get C over B. So then we get B squared equals CY. All right, I'm going to pause here for a second, take a look at this. Note where we got our three triangles from. So hit pause back there if you need a little more time, but we're going to move on to a problem here. So we have that Y, let's change the color here. So we want to find the values of X, Y, and Z. So here we are going to look, we want to first find X. Now, we can set up our proportion as 4 over X equals X over 9. So I'm going to get 4 over X equals X over 9. Now some of you are probably saying, where did you get that? How did you know that? So I can draw out, I have my medium triangle here. And so that's this triangle. So I'm going to label this 9, X, and Y. Now I'm going to draw my small triangle. And I have that's right here. So this is 4, Z, and X. So then you can see that I match up my X and my 4, and then my 9 and my X. So that's where I'm getting those numbers from. So solving for that, we're going to get X squared equals 4 times 9, which equals 36. So we get that X equals 6. I'm going to pause here for a second. Note this step right here. We got X squared equals 4 times 9. If you go back to your note sheet right here, that would be our H squared. So H squared, we could draw the T. So erasing these pictures quick. We got this middle one, and we squared that, and we multiplied it, we made a T. So we took our 4 and our 9 and multiplied those. Okay, so if you can jump straight to that step, go ahead. Else, draw out the triangles, write the ratio, draw the arrows on the figure, whichever works best for you. We got X to be 6. So I'm going to erase some of this, rewind and watch some of that again if you need. Now that we have that length, we can find our Y by using the Pythagorean theorem. So we can get Y squared equals our 6 squared plus our 9 squared. And so we're going to get Y to be, hang on a second. So Y is 6 squared plus 9 squared. So we get 36 plus 81. So that gives us 117. So taking the square root of both sides, we get our y to be the square root of 117, which we want to simplify. And we can split that into the square root of 9 times 13. So we get 3 square root of 13 for our y. All right, now I'm going to erase this and we're going to solve for z. So now solving for z, we'll do the same thing. So we get that 4 squared plus 6 squared is going to equal our z squared. These are just coming from the Pythagorean theorem. So we get 16 plus 36 equals our z squared. So we get 16 plus 36 to give us 52 equals z squared. Taking the square root of both sides and simplifying, we get 2 square root of 13 for our z value. So if you need, rewind. I think once we got to the Pythagorean theorem, it was probably okay, but getting the x value, be careful with that. Again, here, we want to find our x, y, and our z. So we're going to first start by solving for our y value. Now note here, you can go back to your note sheet again and use problem 4 on page 2. So we're going to get that 14 over 5 equals 5 over y. So our 14 over 5 equals y over 5. I'm going to draw out our triangles. So my very large triangle here, I have my bottom is 5, my side is z, and this is 14. And then I have my medium triangle, where my hypotenuse then, so my medium triangle is right here. So then my bottom is my y, my hypotenuse is my 5, my side is x. So I can take my 14 over my 5, and then my, sorry, I want this to be 5 over y. So then I get 5 over y. So draw out the triangles, write the proportions. Like I said, I drew the arrow, so 14 over 5 equals 5 over y. So if drawing the arrows like that helps, find a method that works for you. So we're going to get that 5 squared equals 14y. So we get that y equals 25 over 14, or we can write that as a decimal of 1.79. So we get y to be 1.79. And now that we have one of them, we can use the Pythagorean theorem to solve for the rest. So we get that x squared plus 5 squared. Oh, hang on. Our medium triangle here, we get x squared plus 1.79 squared equals 5 squared. Solving all of this out, we will get x to be 4.67. And now we want to solve for our z. So we can then solve for this length right here. Yes, this is drawn very misproportionally. So we get this to be 12.21. So then we get that 4.67 squared plus 12.21 squared will give us our z squared. Typing that into our calculators, we come up with z equals 13.08. Oh, hang on. Pause that. That works, but we also Note that we have our large triangle. So we can take 5 squared plus z squared equals 14 squared. So then we get that z squared equals 14 squared minus 5 squared, which gives us 171, which we can write as the square root of both sides. We can write that as 3 square root of 19. So either way there works. Last one. Hang with me. So here we have our middle one. So we're going to take and set t plus 1 over 12 equals 12 over 24. So that equals 12 over 24. Cross multiplying, we're going to get 12 squared equals 24 times t plus 1. So we get 144 equals 24t plus 24. Subtracting, we get 120 equals 24t. Dividing by 24, we get t to be 5. So yes, this is a little tricky. It's a long video. So rewind, watch the parts that you need, come in, ask questions. Good luck.